My name is Oleg. I work for Netify. I also do my best to improve reactivity and to contribute to Project Reactor and this amazing network protocol called RSocket. And also I'm trying to contribute to learning and studying of our local community, Ukrainian community, by helping and organizing Devoxx Ukraine and GEConf and local Java user group meetups. So, what we are going to do today? What our main agenda for today's talk?
Today we prepared for you one amazing demo application. We will start with what is the purpose of the application, what we want to achieve, and then we will start step by step to show you how we can build this application using just functionality provided by Project Reactor.
So what the application we are going to build today?
We will have application that will consume data from Twitter as a backend service.
So we have a Twitter service as a main source of data?
Yes.
Okay.
And we are interested in not all tweets over there, but just tweets with one particular keywords.
Okay, we are going to share keywords later, but the main idea of our application is just consume messages from Twitter and display them on the world map. One more point is that the internet on the venue is really shit as usual. So everything could happen. We hope that our demo will work because we need to connect to Twitter, but anything could happen, so be prepared. All right, so we need your help first of all, because we need to consume messages only related to specific hashtags. So we encourage you and we would like to ask you to start tweeting about Devoxx, because Devoxx is an amazing conference which we are handling the first in Ukraine, and this is really amazing because we have a lot of amazing speakers there, so it's really cool and I love it. And I love it, another thing, I love Project Reactor. So I'm going to ask you to start tweeting about Project Reactor. And in order to encourage you, I would like to share and give away this printed copy of this book to the most active person in Twitter with these hashtags. So this is what we are going to do. So if you are interested in reactive programming in Sprint, just start tweeting as much as you can. In case if our demo won't work, we are going to give this book for the most interesting question. So we have two options to share this interesting book. All right, let's take a look at our demo first. Here is our application. I'm not pretty sure whether it works or not, because it could happen everything. But in general, we have a UI which accepts messages from Twitter and display them as a point on the card. So we have tweets about Devoxx almost from everywhere, which is amazing. And on the left side of the screen, you can see the scoreboard of the most active person in Twitter with those tags. All right, let's check whether our application works. Okay, it doesn't work. Let's try it again to check whether we will be able to establish connection, but let's try to talk a bit about how we can build this application using Reactor ecosystem. Can you say a little bit more about Reactor Netty, since you are the maintainer of this project? Can you explain what is the main purpose of this project and why do we need it?
What we need as a start is to have a server that will serve our requests. But we do not want any kind of server. We want a server that is non-blocking and asynchronous. What is Reactor Netty? Reactor Netty actually adds reactive streams bridge on top of Netty so that you can use the reactive API over Netty and thus achieve the reactive application development. Then, can you tell me how many of you know Netty? Okay, most probably you know how complex it is to create a server or a client. So Reactor Netty actually hides this complexity and exposes a very simple API for creating server and client. Also prepares the pipeline for Netty and translates everything to Flux and Mono because we use Reactor Core, which is Reactive Streams API. Most important, we support back pressure. So
sounds good. So we should use in our application as the middleware Reactor. I guess we should use it one more, not only because this is an amazing engine, because this is a central reactive engine for new Reactive Spring and new Reactive Spring WebFlux. And Spring developers love Reactor Netty because it's really efficient and fast reactive engine, right?
Yes.
Am I understood correctly?
Yes.
So, okay, we are going to put Reactor Netty as understood in the middle of our application and start sending tweets over this application based on Reactor Netty. However, how we can use this Reactor Netty? Can you show and explain how we can create, for example, HTTP server?
Let me show you, just to open the IDE. We prepared our repository with, for a demo application with commits. Every commit is related to some functionality that we want to explain you. So now I will switch to this one that will show you Reactor Netty.
Also, we are going to share all the code base at the end of the presentation, so you will be able to play at home with this amazing technology.
So first, we specified here that we will use Reactor Netty. And now, if I want to create a server, what I missed to tell you that we support UDP, TCP, and HTTP protocols. So depending on the needs that you need, you will be able to create server and client for these protocols.
So as I understood, there is a few options to use Reactor Netty. There is a UDP server, there is a TCP server, like clean TCP server, and there is HTTP server, right? So now we are going to create UDP server, right?
Yeah, that's one, just creates a UDP server ready for configuration. But as we do not need UDP server today, let's create HTTP server.
Yeah, I guess the HTTP server is the most useful nowadays, because almost of the audience does HTTP interaction between client and server, I guess.
Okay, it's again very simple. You just invoke create and create an HTTP server ready for configuration. And now I will say that I want to bind that server on port 8080 and bind it.
All right, what else?
Wait for a moment, I will use just shortcut here. And that's all. But when you want to serve some requests, you need some I/O handler. You need to know what kind of URI comes, and you, based on this URI, you want to return different things. For example, I will need 3 endpoints for the demo today. 2 of them will be for serving static resources, and the third one will be for serving server-side events.
So Reactor Netty allows us easily to serve files and create some routine, right?
Yes.
Okay, let's see how we can do that.
For example, if I want to serve SSE, server-side events, I'll specify that. And for that purpose, I will need to implement some handler that will know how to send the server-side events, because the server-side events has a specific format and we need to prepare it. But before that, I will need the information from Twitter. For that purpose, we have here one service. I will need to specify our keywords.
Right, because we are looking for Devoxx and Reactor tweets. Yes. So this is important. You have a huge amount of tweets keywords there.
So here are our keywords. Then this service prepares one WebFlux with tweets based on the Twitter SDK, and then we can obtain it. So in my application, I will just call it like that.
Yeah, I guess it's worth to say that we are not going to see how to work with Twitter API, with Twitter SDK, how to work with basic reactive stream API, but we are going to look at how we can reuse and utilize the rest of Reactor ecosystem. So now we are going to focus only on Reactor Netty API and how we can use Reactor Netty, right?
Yes. What we need here? We need the raw tweet type.
I guess we need tweet type.
Raw tweet. Let me check the stream. Ah, we have flux.
Right.
Okay. So now I will just call the SEC handler for serving that thing. But actually, how I can implement that?
So the good question is how to provide SEC handler.
Yeah, I have here the request and the response. If I need something from the request, I'm able to obtain it. But here for server-side events, we need just the response. On the response, we have to specify first the header, content type.
Yeah, content type is really important.
Yes. Then, as the server-side events stream is infinite stream, you have to instruct Netty that we need flush after every tweet. Otherwise, we cannot wait for the end of the stream. So let me just provide the option. And at the end, I need to send the data. But as I said, the server-side events has some specific format, so I need to transform them. And now I can map that. And invoke. Just like this. And that's all. I implemented here one very quick handler that will return a server-side events.
Okay, what about the handling of resources? So I guess we can quickly switch to the final implementation and show how we can use and build the same handler for resource.
Let me check what's... Yes. Okay, here we can specify two additional routes. The first one will serve something coming with path parameter file name. And then we can invoke the handler for the static resources. And we need additional one here for serving again some URI. And now let's go there and implement the handling of the static resources. As you saw, I specified that I will receive the file name as a path parameter. How can I obtain that? It's really very easy. I can obtain it from the request. And here I have something from my notes so that I do not type it. When we receive just an empty string, we know that we will return the index HTML, otherwise we will return the file that is requested, and at the end, we will return that file. And that's all. We are using just the
Let's try to run our application right now and see whether it works or not. I hope internet is available right now. At least we may check it. So let's try to see whether we have internet or not. Let's try to connect to Devoxx speaker again. And while we are doing that, let's try to run our application. Yep. Let's stop it and let's run it again. All right, we have to update, of course, dependencies, refresh everything, and yeah, let's run it. No, it doesn't work. Okay, I guess we missed one part, one important part, which is we have to just start and block to our application. Since everything, I guess, is reactive, we need to be reactive as well, and we need to keep our main thread, right?
Yes.
All right, so let's restart our application again and believe in the best. Yeah, no, we don't. Okay, we don't have any connection. Let's try to use another Wi-Fi. Always the main problem with live demo is internet connection as usual. Okay. So let's try it. Believe in the best. And let's reload our application. So looks like it works. The internet connection is slow, I guess, but it shows that there is some messages, right? Okay. So let's go back to our slides. And what I learned from this point, what I saw is that the creation of the server with Reactor Netty is much easier than with the pure Netty, because we don't have to tackle all this Netty complexity. Also, what I saw, it's really easy to serve resources. And first of all, we serve these resources reactive, non-blockingly, and asynchronously, which is important. And what I saw, it's also really easy to provide how we would like to handle our routing with pure Reactor Netty. And finally, it's really easy to build logic because we have Project Reactor as a main dependency, as a central dependency of Reactor Netty. So we can use all the huge amount of Project Reactor operators in order to build and handle all the data from incoming requests. So this is good. However, I think there is an important thing to learn a little bit more about the Reactor Netty maintainer and understood what is the state and what is the future of Reactor Netty.
Okay, the good news is that we just released 0.83 yesterday. As I told you, you are able to use UDP, TCP, and HTTP, create servers and clients, and use reactively. We have support for HTTP2 for the server, and we plan with the next versions to have HTTP2 for the client.
Whoa, so we can use multiplexing of all data using Reactor Netty client. Cool, sounds good.
And latest but important is actually out-of-the-box metrics, because one modern application needs metrics in order to understand what's going on there.
Yo, sounds good. However, I guess what I saw from the application and from the current design is that our application is not resilient enough. We have a direct communication with Twitter SDK, and as far as I know, Twitter SDK isn't that good as Reactor Netty. So Reactor Netty has a built-in backpressure support, but Twitter SDK doesn't have that support, right? So our application could be killed and overwhelmed by tweets from the Twitter service.
Yes, true.
Because Twitter service don't know what our possibilities and how many messages could we handle. So this is a problem. And do you have any idea how we can solve it and how we can handle that?
Maybe Kafka. What do you think?
Yeah, sounds like a plan. So how many people knows what is Kafka? Almost everywhere. So Kafka is really efficient message broker. It's a distributed message broker, and it could handle a lot of messages with high rate. So we can put Kafka between Twitter service and between our application. So Twitter will send messages to Kafka, and we will consume messages from the Kafka.
Yeah, but I want to use Reactive API everywhere.
I have a good news. Fortunately, we have a Reactor Kafka in the Reactor ecosystem.
Wow, can you talk more about this?
Yeah, so the main purpose of Reactor Kafka, as for Reactor Netty, is to provide a reactive stream API, but in this case on top of Apache Kafka. As well, Apache Kafka has its own complexity in the usage, especially when we would like to provide some streaming model. And Project Reactor with integration with Kafka hides this complexity and provide built-in streaming API using reactive streams and Project Reactor. And finally, Reactor Kafka has built-in backpressure support, which is important for us because the stability of the system is one of the important key features of reactive system and modern application. So we are going to use Reactive Kafka client and sender, receiver and sender in order to consume messages from Twitter. Then all these messages will be enqueued in the Kafka, and when our service will be able to handle some messages, it will send us to Kafka notification about that, and Kafka will send a tweet, so we will be able to show new tweets on our UI. So let's take a look how we can use Reactor Kafka. I'm going to switch to the next step of our presentation of our application. Let's do that. So we are going to switch to the next step. We are going to update our dependencies, of course, and let's see what we have in our app. Now we have two applications, because one application consumes messages from Twitter and another one consumes messages from Kafka. So the first one is Kafka adapter or Twitter Kafka adapter, and what we want to do there, we are going to how can I do that? Check out revision rate. Yeah, first check. Yeah, that's what I want. So at this part, we are going to consume messages from Twitter. So we moved our Twitter service and Twitter adapter to this part of the application. And here we would like to understand how we can write our application and run it and send messages from Twitter to Kafka service. First of all, in order to bring Reactor Kafka in our project, we need just to use this dependency. So this dependency brings everything that we want. It brings Reactor, it brings Kafka client, Kafka sender, Kafka receiver, and first of all, a wrapper around that. So in order to send messages to external service, we need Kafka sender, and we have it in Project Reactor. So there is a Kafka sender which allows to create some sender client, so we can use it API. And the main few messages that we would like to have is basically understand how handle the producer in case if we need to process the real producer. For example, we want to send messages in transaction. This is an important feature, so we can send messages in transaction. And we may just simply send messages, which we are going to use in this sample. Here, we are going to use, of course, we need to use, again, we need to connect to Twitter service, to Twitter API, and get the tweets flux. And we need to create a Twitter service, consume stream, and that's basically it. Then what we want to do, we want to send messages. However, one of the options is that we have to wrap our messages to a specific kind of wrapper or message related to Reactor Kafka. So then we are going to do the following. We need to map our flux to, in this case, it's sender record. Let's check it. What is the implementation do we have? So this is the main class that just have, which is a part of Reactor Kafka. So it just have a simpler API which allows us to create producer record, which is a part of original Kafka client, and that's basically it. So let's wrap everything in the. Here we got a tweet, and here we want to create. Let's take a look. A sender record. Create new producer record, and here we need to put some information. So producer records requires just basically a topic name, which in our case it's tweets, and yeah, another part is value, which is the most important. Okay, it's a key and value, so tweets enough, and yeah, we are going to put tweet, and we need, I guess, a correlation ID, which is some correlation metadata, which could be a tweet again, and that's basically it. Along with that, we need to specify to which endpoint we need to connect. So we need to provide, I have a specific Kafka commons, which allows me to easily just use Kafka configuration from this property file. So I have a basic configuration of Kafka server there, like serializer, deserializers of the messages. And I'm going to use these Kafka commons in order to load the resource, like Kafka properties. And yeah, that's basically it. Sender options. Yeah, we need sender options. What's wrong with that? Okay, I need a pass. So I'm going to quickly switch to a complete sample in order to just don't waste our time. In order to just, what's wrong with that? Okay, that's the current point. And yeah, we're going to load the resource, create our client, and send the stream of messages. Here I'm going to use, in this case, I'm going to use a little bit better API. Previously, I did something like that. So I just use Kafka send or send, but it doesn't matter. We may use it more functional, or we can use it in the more readable way. It doesn't matter. And we need to block. Why we need to block? Because we need to keep our main thread, and we need to keep our application running. And since we consume infinity of stream of messages, we just need to just block, and that's it. And this will keep our main thread working. So now let's try to run our application. And hope this time I'm going to achieve and establish the connection with Twitter. On the other hand, we need somehow to consume messages. Yeah, we achieved the stream, which is good. On the other hand, we need to consume somehow messages. On another part, which is UI part of our application, we use almost the same API. However, in this case, we are going to use Kafka receiver. We use the same Kafka commands in order to load Kafka properties, and then we need to specify from which endpoint we would like to consume our messages. So in this case, we will going to consume from one topic, which could be subscribed. We may subscribe more topics if we want, but then we don't want this for the demo purpose, and we would like to consume only from one topic. Then we say, okay, receive messages. There is more option how we can receive messages. We may receive with a specific acknowledgement mechanism, or we can receive with different guarantees. And for example, we can specify that we need exactly one, this message exactly one, so we need to do that in some transaction or something like that. But there is a few options. However, for our demo purpose, we just use the simplest one, which is just receive messages. So we receive a record, we need to say, okay, we received that offset, we need to commit that we read that message, and we may return the value within that message from the Kafka. This is basically it. If we're going to run our application again, okay, let's restart. We have a problem with network as usual, so I have no clue how to solve that. Okay, it's a different application. Yep. Okay, let's try to run it again. And let's try to, yeah, we have some messages from Baruch, from me, and yeah, looks like it works. I hope it works. And let's back to our presentation right now. So we can summarize and say that Kafka has reactive reactor-based consumers, so we can consume messages using Project Reactor. We have a different approach in order to, like Reactor Kafka give us a different approach in order to deliver messages and consume messages as well. So Reactor Kafka has a built-in backpressure support. It's less visible, but believe me if I tell, Reactor Kafka has backpressure support, and it's guarantee that we won't consume more that our subscriber requested, which is important for stability and resilience of the application. Also, yeah, so how it works right now. We are going to,
I wanted to ask you actually something. Yeah. If I remember correctly, with the Twitter SDK, there are use cases where you cannot obtain location of the tweet. Is it true?
There is a problem with the Twitter SDK. First of all, Twitter doesn't guarantee that we can always receive the location of the tweet, because in this case we are going to spy everyone and we will know where is the person is located or where is this person is tweeting from. And for this purpose, we need to solve this problem somehow. For example, we can use...
Can you use third-party services?
Yeah, we can use. For example, we can use a Mapbox service, which allows us to say, okay, we have some information about location. For example, we have word Ukraine, we have word Kyiv. So based on this word, we can understand from which city or from which location this person is tweeting. So we are going to use this Mapbox API, and what we are going to do, we are going to consume our messages, send to Mapbox our consumer tweet, and then receive the location of this tweet, from which this tweet has been sent. So
we will
let's take a look how we can.
Cases,
let's take a look how can we do that. All right, can you show me?
Yes. Let me switch again to the IDE.
Okay.
Stop.
The Twitter consumer crashed again, which is not good.
Let me check out that one. And I need to update again the project because I need to update the project dependencies.
Yeah.
And now, let me open now the integration with Mapbox. What we have here, we have some API so that we can provide the information for the user location to this API, contact the remote service, and then wait for a response. And from that response, we will be able to obtain the longitude and latitude.
Okay, so this is a remote call to external services. And we use, in this case, some SDK, but it says SDK reactive and non-blocking, because in case, for example, we could use Reactor Netty client, in order to communicate with external services. However, as far as I remember, this service doesn't have any public HTTP API, which is a problem. Do you know how this client works?
It uses actually a blocking client app. So we do not want to use a blocking client.
So, as far as I remember, Mapbox uses retrofit. How many of you are familiar with retrofit? Okay, a few hands. So, in a few words, retrofit is a HTTP client or kind of HTTP client which allows us to access some external services. Under the hood, it uses okhttp, which is kind of similar engine to Netty, but it's for mostly for Android. And the problem with okhttp is that it's blocking. However, there is a useful API which allows us to change the transport, as far as I remember. Is it correct?
Yes, that's true. We have a component that provides us Reactor Netty HTTP client for that purpose. And what we need is just to specify it here. And from now on, we will contact this remote service using non-blocking asynchronous.
Oh, sounds good. So what is the main purpose of Reactor okhttp integration and how it works? Does it use under the hood the Netty client, Reactor Netty client?
Yes, let me open that factory and show you. Again, as like with the server, we just invoke create and we create HTTP client ready for configuration. Here, we can specify the headers that we want to apply to the request. Then we can specify the type of the request, the URI, and whether we want to send somebody with that request or not.
Looks like really useful builder API.
Yes, you can see how easy we can retrieve the response from that remote service.
Yeah, looks good. So let's run our application again. Let's try to run it at least. Maybe this time it will be better.
Yes.
Is our Kafka consumer works right now?
No, I stopped everything. Let me start now the application.
Okay, we have the same problem with the network, as usual. However, let's talk a little bit about Reactor okhttp. Can you say a little bit more about this project and the main idea of this project?
As I said already, this project provides a non-blocking asynchronous HTTP client that you can use in order to obtain information from your remote services.
Okay, this is in case if you are using something like retrofit or okhttp. So this is non-blocking transport for okhttp.
Yes.
All right. So let's move further. Looks like we start using Mapbox API. However, I guess the Mapbox API is not a free service, right? So it's a paid service. And as far as I know, our service is consume messages from Twitter, send it to Kafka, then we request messages again, and send it to Mapbox.
But what happens if we have users from Kyiv, a lot of users from Kyiv?
Yeah, so we are going for each user from Kyiv, send message to Mapbox and retrieve the same information again and again and again and again.
Really?
Which I guess a big problem. Fortunately, we can solve it really easy with, let's do it quickly. With Reactor Extra. So let me explain what Reactor Extra, what is the main purpose of Reactor Extra. Reactor Extra is nothing more than superset of useful features and operators on top of Reactor Core. So this is not a library, this is not a specific framework, this is just a superset of add-ons and additional features for the main Reactor Core. So one of the key features, for example, is ability to work with tuples. So how many of you know what is tuples? Okay, so in a few words, for those who don't know what is tuple is a kind of tree which allows you to access some different branches. So for example, let's take a look at this code. We have two streams, one stream of number and another stream of, for example, letters or words. So we would like to zip these two streams, and as a result of this zipping, we will receive a tuple, which has a branch of numbers and a branch of, for example, strings. And we don't like to work with this boilerplate. We don't like to each time get the, for example, the number, and the API is less readable and less understandable. So fortunately, Reactor Extra provides us a set of utils. For example, we may deconstruct the tuple using, for example, tuple utils function and handle the incoming tuple as a two separate parameters to the function, which is really, really useful and hides a lot of boilerplates for us. Another feature is, for example, an ability to work with mass feature in the reactive way. For example, MassFlux allows us to, for example, calculate average double from stream. And there is a lot of functions which allows us to calculate the result of the stream using some useful mass functions. Another feature, Reactor add-ons and Reactor Extra brings us an ability to integrate with Swing. I have no idea, I have never used this this UI project for forms, for building forms, form application. But the most important, Reactor Extra brings us an ability to work with cache, which is really, really useful. For example, Reactor Extra allows us to build the following construction. Suppose we have a map to which we would like to cache something, so we will look up at that map the following key, and in case if we found it, we will send it downstream and we'll process the result asynchronously and non-blockingly using that API. In case if the cache is like we don't have this key in the cache, we are going to call the sub function like we can specify the action on the missing cache, and we can resume with, for example, external call to, in our case, Mapbox API. So what will happen in this case? So we will do almost a similar operation. Then we are going to look at the cache where we have location for this tweet or not. In case if we don't have any information about this tweet, we are going to call Mapbox, cache this information, and return it to our server. In case if we have this information or we got the similar request or tweet from the same location, we are not going to call Mapbox again. We just return the information about location from the cache and send it to UI, which is cool. Let me show it. Let me do it really quickly. I'm not going to write all this stuff. I'm just quickly switch to the next stage. And that's basically it. Let's do that. And let's see how we can optimize our application using, for example, Reactor Extra. In this case, I'm going to use cache mono. Along with cache mono, I have cache flux, which allows us to retrieve the stream of messages from our storage. But in our case, we just need to store only one element and look up for only one element, which is user location, specified as a string in this case. Then, in case we miss our cache, we are going to call, of course, external services, and then, after all, process the result and send it back. Okay, let's try to run our application again. Oh, it looks like it works. Let's restart it. Yeah, we consume some messages. Cool. Yeah, we consume it. No, we don't. Okay. Okay, at least we have some information now on the screen. All right, let's move forward. We have not that much time. And let's talk about the final part of the modern application. I guess the most important part of the modern application is understand what is going on within this application in case if it's crashed. So I guess everyone in this room do some login. So how many people in the room do login on their services? Okay, that's cool. So in this case, what we would like to achieve is maybe reactive kind of login.
Yes.
So can you explain briefly what is Reactor logback?
With Reactor logback, we provide a special aggregator so that you can log non-blocking your events to the file system, for example. What we have is just one additional configuration in your logback file, configuration file. Just specify Reactor logback async appender, and that's all.
So let's see how we can do that, and let's see whether we will have some benefits from using Reactor logback in our project.
Let me go to the correct commit. And update the dependencies.
So, in a few words, in order to use Reactor logback and understand whether we have some benefits from using Reactor logback in our project, we are going to do some login into the file. Can you show us
Yes,
where we have?
Here we will start first with the configuration. Actually here, that will walk to the file, and we will use blocking.
So I guess we need to comment this part in order to check how much time is spent on login without reactive engine and reacting login, and then we need to understand how much time we can save with this engine. All right.
So for that purpose, we prepared here a lot of logging. Then we try to obtain the time that we need for this purpose. And let's start it.
Since we have some messages in Kafka stored in the Kafka, we are going to, I guess, receive some of them. And then we will be able to see the result of login in the file. This will save us.
Yes.
Okay, let's see to the file. Do we have some login information there?
Unfortunately, I don't think we have problem with our application.
Okay, this shitty internet, it's
yes,
always
you can
happy.
believe us that everything is what we say. Here, instead of using file appender that uses blocking, we will use async.
And in this case, we are going to use asynchronous writing, non-blocking writing to our I/O.
Yes.
In a few words, this kind of technique could save like a half of the time spent on the writing data to the I/O, which is a huge amount of time for in case we would like to have login. All right, let's do the final summarize of what we did during this kind of strange demo. First of all, we would like to say that reactive ecosystem is really huge, and along with Reactor Netty, along with Reactor Kafka, along with Reactor add-ons, extra, there is amazing project, and there is an integration with Reactor RabbitMQ, like with RabbitMQ, and there is Reactor Redis, which allows us to use Reactor in order to communicate with Redis and with RabbitMQ. Along with that, we can build a complex application like that using just a pure reactive ecosystem, which is cool as well. And finally, we can build really efficient and resilient system using this technology. And we don't need the whole Spring ecosystem in order to build such kind of application, because Reactor itself has a lot of powerful features, and it provides really simple API in order to build powerful application. Finally, if you would like to learn a little bit more about Project Reactor, just follow this link. There is a huge amount of project that you can find under the Reactor umbrella. So we have, along with Reactor core, we have a Reactor test which allows us to test our application, Reactor Extra, Netty, adapter, and so forth and so on. And not only the Java, there is a Reactor.NET and JS, which is also amazing. Finally, if you would like to play with this code base, you can follow this link. And if you would like to read this presentation again, here we have a link for you. First of all, thank you for your attention and have a nice conference. As I said at the beginning, if we have a failed demo, which we had right now, the most interesting question about Reactor will win this book. So if you have interesting question regarding Reactor ecosystem, or you find a bug, just ask. Yes, please. Can this guy have a microphone?
Thanks for the presentation. I have a question regarding the back pressure you mentioned in the Kafka proper.
Yep.
Is it really a true, real pool-based back pressure? And if so, then how do you handle offsets? How do you maintain them?
So the question is, do we really have real back pressure in Reactor Kafka? So the answer is and yes and no. So we have a real back pressure because, as you could know, Kafka has a pool client. So Reactor Kafka is just a wrapper around this pool client. So the mechanism of Reactor Kafka, for example, receiver is the following. In case if downstream requests some data, it requests some specified, for example, prefetch size. For example, we would like to prefetch first 100 messages. It prefetch these 100 messages and keep them in the memory. Then downstream will going to consume those messages one by one, and once we consume them all, the Reactor Kafka will going to ask for the next batch of the messages. This is how the reactive back pressure works in this case. The second part of the question, could you repeat it again?
Well, it's about the offsets. Is it possible to control them somehow, or what's the mechanism?
Yeah, as I saw in the demo, as I shown in the demo, let me show the Twitter API. Here we can control the offset by say, okay, we received that message. It has some offset, so we can commit that offset. Commit provides us a synchronous way to commit offset back to Kafka, so we can do that asynchronously as well. And once we do that, we can, for example, retrieve the original message that were sent through the Kafka. So this is one of the options how we can do that. Another option, we can provide auto-acknowledgement. So Reactor Kafka will do that for us in a separate thread. It will do that, for example, once per second, or you can specify it using, for example, let me show it. You can specify commit interval using the Reactor Kafka options and use it in this way. So in this kind of technique, you don't have to care about the committing of the messages, and you can move it to Kafka itself. However, there is some benefits of using that technique, and there is some risks of using this technique, of course.
Is there any way to control offsets manually by the client?
Yeah. So this basically will.
I mean, not just using the built-in things like not committed to Zookeeper, but maintain them on the client side. Am I making myself clear? Or?
I guess I don't get the question, because this is client side. So this is the receiver part.
Yeah, but okay, never mind.
Okay.
Thanks for the answers.
Okay. Any other questions? Okay, I guess here we have a question.
I have one small question. How you handle Kafka consumer groups in this Kafka receiver?
So the question is, how can we handle consumers group? Oh, so the consumer group could be specified in the options. In this case, I'm using the consumer group like this in the file. So I specify the group ID, and yeah, you could do that through the options. So there is a straightforward way for that. You can do that through the file, or you can do that again by passing the specific options to let me show it. Yeah, you can do it with some specific consumer properties. So you can specify it and pass it to Reactor Kafka options. Yeah.
Can we configure how many consumers will work? I mean Kafka consumers.
In that, like, this is a good question, because for now there is some issue in Reactor Kafka. We can't specify how many consumers we would like to handle, and this is one of the feature requested from the community, so we are working on that right now.
Okay, thank you.
Yeah, please.
I wanted to ask you about service and events via Project Reactor, and can we keep in mind that Flux can replace servers and events with Angular features, Angular 5 and 5+ versions, and can Project Reactor.js help us to replace server sites and client sites with using of SSE? Thank you.
So the question whether we can replace Angular event processing or...
for example, I use Spring 5 with Flux and service and events. And I use Angular HTTP with like observable, not opening event source on client side. Just I wanted to subscribe on client to stream from server. Can I achieve that with using of Project Reactor.js and Project Reactor for Java?
Yes, I guess you could. Like as you saw in this demo, we use it as you can show it, for example.
Yes.
Again.
This is how you can return server-side events from Java.
Yeah, but can we consume that stream on client without event source?
Without events.
Without opening event source.
I guess we can't do that, because this is like a HTML5 API, and this is HTML5 standard, which says you should use this, for example, event source API and this event source JS client in order to handle messages. Then you can build on top of that some Reactor API in order to handle. For example, let me show you. There is for example, in our case, we use reactive front end as well. So we have something, we use observable Redux. We don't use Reactor, project Reactor.js in this case. However, we use RxJS, which has also a powerful mechanism for handling data. So in this case, we just adapt event source and listen to incoming messages and just supply those messages directly to observer. So this is one of the options. The same API has in Project Reactor, but we decided to use it because there is integration with Redux, and that's only because of that.
Okay, thank you.
There is another one.
Yeah.
I have one question. In your presentation, you have used a cache to receive the location from Mapbox. So it's quite huge information. So I have a question: if we can limit that cache, and if there is a tool there.
Like in our presentation, we used in-memory cache. One of the options, you can use another, for example, implementation. In this case, we use just a concurrent map for that. So it's just the simplest implementation as possible. As I said, there is a Reactor Redis integration, so you can use Redis, for example, for storing your data, and Redis in Redis you can specify, for example, as far as I remember, the lifetime of for example, the value, but I'm not sure. Or you can use another implementation of the cache, like in-memory cache, which, for example, Caffeine, which could in which you could specify the lifetime of the event or the size of the cache.
Okay, thank you.
Like in this case, Cache Mono just provide a convenient API for handling cache. Okay, I guess the most interesting question was about Kafka, so please came and take, you.
And if you have more questions, we are here, so find us and we will answer you offline. Yes, thank you.
Thank you for your attention again, and have a nice day.